Hi, in this video we will learn about limit laws. These are tools through which we can compute limits of functions that you create from the older functions, adding them, multiplying them, dividing them. If you know the limit of each piece, how the limit of the total or at the end the big function will look like. Well, let me start from this two easy facts that we were able to check by our experimental approach to the limit definition. First thing was that limit of constant number as x goes to a is always constant, c constant. And limit of x itself as x goes to a is a, so for all a's here. So these are basically the simplest facts we can see. Now we need a little bit tools that can help us to make more complicated functions using these two things. For example, polynomials, rational functions, and so on. So this is where limit laws comes in. Sometimes, you can say that operations and limits. So how the limits act with respect to the adding, subtracting, multiplying, and so on. So we are assuming that there are two functions, f of x and g of x. Their limit as x approaches to a exists. One is L1 and the other one is L2. Now, what about the limit of their sum? Well, this is the first, it's called sum law. It says that, limit of sum is sums of limits. In other words, if you know each summand has limit, then the total sum will have the limit L1 plus L2. This also have a difference law, which says the limit of, let me write it here, limit of f of x minus g of x. If you subtract, it would go the same way. So if you know the limit of f of x and then limit of g of x, as x goes to a, you just subtract the limits. That would be the limit of f of x minus g of x. The third one, constant multiple. This is when you have one function and you multiply it by c as x goes to a. Then this, c is a constant, Then c comes out of the limit f of x. In other words, this will be CL. So this is sum, constant multiple. How about product law? Well, product law says that, how about f of x times g of x? As x goes to a, what is this limit? Well, limit and product work nicely together. So if you know limit of each piece, you can multiply each factor, you multiply the limits, then you will get the limit of the total product. The fifth one is quotient law. And obviously it's going to talk about the f of x over gx. Well, we have to make sure that this makes sense to talk about f of x over gx, meaning that, well, we need to g to be non-zero around a, otherwise we cannot divide. Well, this will be L1 limit of numerator over L2 only if the limit of the denominator is non-zero. And that's for obvious reason. If the limit of the denominator is 0, well, I cannot put L1 over L2. Then 0 in the denominator is a big no-no for us. So that's why the quotient law, the limit of quotients is not always equal to quotients of limits. We have to first check that the denominator does have non-zero limit. Okay, let's just use these one. There are two more laws that will come later, but let's just do some examples for these ones and then see how the new ones come in. So use the limit laws to find the limits, the given limits. First one is the limit of 2x plus 1 as x goes to 1. Well, here I have sums of two functions. I can use sum law. So the first one, this gives us limit of 2x as x goes to 1 plus limit of 1 as x goes to 1. Then here there is a constant multiple 2 multiplied to x. We can take that out, but for that we are using constant multiple law. So this is the third law, gives us 2 comes out, and then find limit of x going to 1 plus limit of 1 as x goes to 1. And well, now we have fact 1 and fact 2. We know the limit of x and limit of constant, what happens for them when x goes to 1. So limit of constant is always that constant. Limit of x as x goes to any number is that number. So this is 2 plus 1, 3. Well, that gives us the limit of that function. How about this one, a little bit more complicated one, 3x squared minus 2x minus 1 as x goes to 0. Okay, so let me make, first there are 1, 2, 3 functions. So two subtraction there, so I can use difference law. Here will give us limit of 3x squared minus limit of 2x minus limit of 1. All of them x goes to 0, x goes to 0, x goes to 0. Then use the constant multiple law, constant multiple. And this comes out. And this comes out, and we have limit of 1 as x goes to 0, as x goes to 0, as x goes to 0. For the first one, x squared is x times x. So let me write this. So it means that these are two functions multiplied, and we can use product rule, product law, which gives us 3 limit of x as x goes to 0 and limit x as x goes to 0 minus 2 limit of x as x goes to 0 minus limit of 1 as x goes to 0. Now we are back to fact 1 and fact 2, which says what is limit of constant and limit of x as x goes to a number a. In this case, a is 0, so this will be 0 times 0 minus 2 times 0 minus 1. Well, this is just negative 1. And that tells us everything. Basically, in general, you see that this guy here is that 3 0 squared minus 2 times 0 minus 1. And while we can do similar computations for any polynomial and get what is called the direct substitution property, which says what? Which says for any polynomial px, if you're trying to find limit of polynomial as x goes to a, well, this is nothing but evaluating that polynomial at a. So you don't need to do all these steps. Well, you basically do it in background, but what is important at the end is that the finding limit of polynomial is the same thing as evaluating that polynomial at that point. And that makes life much easier for us. We don't need to do all these steps every time we complete limit. What else we can get from these laws? One of the things that we can do, let us just see another example that will show us everything. Limit of 2x plus 1 over x minus 1 as x goes to 0. Well, this is quotient, so the first thing that comes to mind is what? Quotient law. Yes, quotient law is about the limit of quotients. One thing that you have to check for the quotient law. So the quotient law is true only when the limit of the denominator is non-zero. So we have to first check. Check that. What is limit of the denominator as x goes to 0? Well, this is a polynomial. By the property we just said, this is the same thing as plugging in. And since it is non-zero, now we can use the quotient law. So we can use quotient law. That's one thing that you have to always do. All the other rules, all the other laws, they just go through. But for the quotient, you have to first check that the limit of the denominator is non-zero. So that means that limit of the numerator over denominator, we can find limit of each one separately and then divide them. Yes. But all of these guys are what? Polynomials. So by the substitution law or property, we can just plug in the value there, and that will give us 1 over negative 1. That's negative 1. More example, limit of x cubed minus 3x plus 2 over x squared plus 2 as x goes to 1. This is again a quotient. First find the limit of the denominator. So limit of the denominator 2x squared plus 2 as x goes to 1 is, well, this is a polynomial. We can just direct substitution will give us the limit. So it is 4. It is non-zero, so we can apply the quotient law. So quotient law, then this will give us this fact that limit of the quotient is quotient of the limits. Here, now we have that one. And well, each one of these guys are polynomials, and we can evaluate the limit by plugging in the x equal to 1 in each one. So 1 squared plus 2. This gives us 1 minus 3 plus 2 over 4. And that gives us 0 over 4. Numerator can be 0. Well, that's good. 0 over any number is 0. So the limit of that is a 0. So if you do this thing for all rational functions, you will see that, well, there is a kind of more general substitution property, which says that if P and Q are two polynomials, then limit of the rational function px over qx as x goes to a is equal to basically plug in that into a, but well, this can be 0 in the denominator, so we have to make sure that q at a doesn't give us 0. So that's the quotient law basically shows itself again here by this thing. So when you have rational function and trying to find the limit of the rational the function, check the denominator first. Evaluate the denominator at a. If it is non-zero, you just plug in the numerator and denominator and goes on like that. Well, these are, as you can see, this one helps us a lot to compute limits. There are two more laws that I will add here. So that was up to 5, I believe. Yes, now we get 6, which says this is called power law. Well, if you have, again, limit of f of x, now limit of f of x to the power n as x goes to a. N is a positive integer. Then this is going to be L1 to the power n. So limit of power is power of limit. And the other one is called root law, which is root law, limit of nth root of f of x equals to nth root of L1. Well, here we have to be a little bit careful, because if n is even, this might give us negative number under the square root, and that's a big problem. So here this is true for n odd integer, odd positive integer. Sorry, odd positive. For the even ones, if n is even, that is true, but we have to make sure that L, limit of the function, limit of f of x, which is L1, is a positive number. So this for n even, it is true if this is like that. So let me just erase this. So it means that, well, root law is also true, and you can do it for the functions like that. And well, let's just do some examples for these two examples. Find the limit. First one is limit of 2x squared minus 2x plus 4 as x goes to 1. Here I have the even root, so first I have to make sure that the limit of the function under the square root exists and it is a positive number. But this is a polynomial, so we can just do substitution, direct substitution, and that will give us 6 minus 2, which is 4. It is positive, so that means that we can use root law. This gives us exactly this number, which we already found. Then find the square root of that, which is square root of 4, and that is 2. And one more example. This is a limit of 2x plus 1 over x squared minus 2x plus 2 as x goes to 0. Here we have the root law first. To be able to use the root law, we need to first check that the limit of the function under the square root exists and it is positive. This is now the quotient law, and while we know that these are polynomials, limit of the denominator is non-zero, we can use the quotient law, and basically other version of the quotient, the generalization of the substitution property. So this will be 0 squared minus 2 times 0 plus 2, which is non-zero. That's why we can use that. Then 2 times 0 plus 1, which is 1 over 2. So since this exists, it is positive, then we can go ahead and find the limit first, then find the square root of that as x goes to 0, and this gives us 1 over 2, which is 1 over root 2. You can rationalize and get root 2 over 2. Well, these are the rules and laws, and you can use these ones to compute more limits of more functions. There's a final remark is that the limit laws work with one-sided limits as well. So it means that if you have, let me just go back to the list of laws. If you have one-sided limits like x goes to a minus, this will go through. Or if you have positive, again it will go through. So if you have one-sided limits, you can again use these limit laws, all of them: sum, difference, and constant, product, quotient, and so on. So these laws basically are our main tools in our toolbox of computing limits, and will help us to compute limits of more general functions.